Warahmatullahi wabarakatuh. We are from Group 6. Want to talk about new challenging manufacturing process in automotive application. Okay, this is a memo group. First, Amirullah Hakim bin Sasim Nizam. Second, Shafiq bin Rozali. And third, Noazri bin Sahari. Okay, now we're going to introduction. Okay, what is manufacturing? Manufacturing is the production of products for use or sale using labor or and machine tools and chemical or biological processing or formulation. Such goods may be sold to other manufacturers for the production of other more complex products such as aircraft, household appliances, furniture, sports equipment or automobiles, or distribute via the tertiary industry to end users and consumers, usually through sellers who in turn sells to retailers who then sell them to individual customer. So the manufacturing process begins with the product design and materials specification from which the product is made. Modern manufacturing includes all intermediate process required in the production and integration of a product components. Okay, next we are going to methodology and working principle. The first is raw materials. Okay. Although the bulk of an automobile is virgin steel, petroleum-based products with plastic and veneers have come to represent an increasingly large percentage of automotive components. The lightweight materials derived from petroleum have helped to lighten some models by as much as 30%. As the price of fossil fuels continues to rise, the preference for lighter, more fuel-efficient vehicles will become more pronounced. Okay, next we're going to design. Design is idea for new models developed to respond to unmet public needs and preference. Design equipment. Designers develop basic concept drawings that help them visualize the proposed vehicle appearance. The model, studying airflow parameters and doing feasibility studies on crash test. Models have been reviewed and accepted to designers permit to begin building the tools. Okay, what have the manufacturing process? First is component. The components supplied by more than 4,000 outside suppliers, including company-owned part suppliers. Okay, those parts that will be used in the cases are delivered to one area. Okay, second, this is cases. Okay, what is cases? Cases is the typical car or truck is constructed from the ground up. The frame forms the base in which the body rests, and from which all subsequent assembly components follow. Okay, the frame is placed on the assembly line and clamped to the conveyor to prevent shifting as it moves down the line. Front and rear suspension gas tanks, rear axles and drive shaft, gearbox, steering box component with drum and braking system are sequentially installed. Okay, next we are going to body, the manufacturing process, the manufacturing process. Okay, generally, the floor pan is the largest body component to which a multitude of panels and bases will subsequently be either welded or bolted. As it moves down the assembly line held in place by clamping fixtures, the shell of the vehicle is built. Okay, first, the left and right quarter panels are robotically disengaged from prestige shipping containers and placed onto the floor pan. Okay, articulating arms can easily introduce various component braces and panels to the floor pan and perform a high number of weld operations in a time frame and with a degree of accuracy no human workers could ever approach. Okay, number 4. We are going to process the paint. Okay, the body must pass through a rigorous inspection process. The body in wide operation. The shell of the vehicle pass through a brightly lit white room. Okay, under the light, this oil allows inspectors to see any defects in the sheet metal body panels. Okay, dents and any other defects are repaired right on the line by skilled body repairman. They cover every hook. The cleaning station, it goes through a drying booth and then through a undercut dip and electrostically change back of undercut pen. We can call it the e-coat. Okay, the e-coat that covers every nook and cranny of the body shell, both inside and out, with Premier. Okay, this coat acts as a substrate surface to which the top coat of color paint adheres. Okay, vehicle bodies are spray paint by robots that have been programmed to apply the exact amount of paint to just the right areas for just the right length of time. Okay, number 5 is interior assembly. Okay, workers assemble all of the instrumentation and wiring system, dash panels, interior lights, seats, door and trim panels, headliners, radios, speakers, all glide except the automobile windshield, steering column and wheel, body water strips, vent tops, brake and gas pedals, carpeting, and front and car bumpers fascias. Okay, the windshield from a shipping container, apply a bit or iridescent scaler to the perimeter of the glass and then place it into the body windshield frame. Pick seats and trim panels and transport them to the vehicle for the ease and efficiency of the assembly operator. To ensure the proper fit of the panels, glass and with the stripping, it is now ready to mate with the cases. Robot also pick seats and trim panels to transport them. After passing through the section, the shell is given a water test to ensure the proper fit of the panel glass and whether it is now ready to make the cases. Now we are 6 process. The last process is made. As the cases pass the body conveyor, the shell is robotically lifted from the conveyor fixture and placed onto the car frame. assembly workers, some in ground level and some in work pit. Going to quality control in the methodology and working principle. Okay. This is the 1,000 of component piece that comprise the car must be manufactured, test, packaged and shipped to the assembly plants. Often on the same day they will be used. Most automobile manufacturers require outside parts vendors to subject their component parts to rigorous testing and inspection audits similar to those used by the assembly plants. The assembly plants can anticipate that the products arriving at their receiving docks are statistical process control, the name short form SPC, approved and free from defects. Okay. Once the component parts of the automobile begin to be assembled at the automotive factory, production control specialists can follow the progress of each embryonic automobile by means of its vehicle identification number, or we can call it VIN. Okay. In many of the more advanced assembly plants, a small radio frequency transponder is attached to the chassis and floor pan. This handy unit carries the VIN information and monitors its progress along the assembly process. Quality control was seen as a final inspection process that sought to discover defects only after the vehicle was built. In contrast, today, quality is seen as a process built right into the design of the vehicle as well as the assembly process. Okay, vehicle recalls are costly and manufacturers do everything possible to ensure the integrity of their product before it is shipped to the customer. Okay, the final audit test for properly fitting panel dynamic, skids and rotors, fashioning electrical components and engine cases and wheel alignment. Okay, that's about quality control. Next, we go in the future. Okay, the future, the electric automobile will owe more to innovative solar and aeronautical engineering and advanced satellite and radar technology than to traditional automotive design and production. Okay, the electric car has no engine, exhaust system, transmission, muffler, radiator, and spark plugs. This power will come from alternator current, or we call it AC, electric motors with a brushless design capable of spinning up to 20,000 revolutions per minute. Okay. New electronic vehicle technologies that permit cars to navigate around the congestion and even drive themselves may soon become possible. The electric car will come because of a rare convergence of circumstance and ability. Okay, next we are going 7 challenging manufacturing process for automotive application. Okay, first about environmental impactment. Okay, the global automotive industry is under constant pressure from environmental and customer demands. Okay, next, the industry is facing issues regarding fuel economy, gas emission, safety, and affordability. The competitivity pressure on cost, quality, performance, and manufacturability of the vehicle today are bigger than ever. Okay, response of the automobile industry is merely centered around the selection of lightweight materials that the performance and cost requirements, thus improving the efficient and fuel economy of vehicle. Okay, next about the fuel economy and CO2 emission. Okay, vehicle produce greenhouse gas emission during their entire life cycle. Rate CO2 emissions from the transport sectors accounting for about 30% of total CO2 emission in the EU. EU is European safety, or easier to know about it is European safety OSHA, like OSHA, safety OSHA. Okay, second, emission result directly from the use of the vehicle, 85%, while the other 50% is a result of the manufacture of the automobiles, including material production. Okay, the average CO2 emission performance of new EU passenger cars was investigated. The CO2 emission of 9 major manufacturer groups were grouped together and analyzed for how well they meet CO2 standards. This is a graph about CO2 emission from 2015 until 2020. Okay, we could look here, have CA, HA, Hyundai Motor, Company Ford, Volkswagen, Renault, Nissan, Toyota, BMW, and Daimler. So we look here, Toyota is less use CO2 emission in vehicle. Okay, we look here, Toyota very low. Okay, Hyundai Motor and Company Ford is very high. They use the CO2 emission. Here in 2017, Toyota had the lowest CO2 emission out of all manufacturer. Okay, about the Fiat Chrysler automobile group was in the worst position to meet in 2020 target. Yeah, like this. 2020 and 2021 is target the Fiat. Okay, the average CO2 emission for a vehicle will have to decrease by approximately 24 gram or kilometer, 20% to meet 2020 or 21 CO2 emission targets. Okay, next, steel contribution. Okay, steel contribution is the new regulation for safety and crash improvement has challenged the steel industry to develop steels with unique microstructural combination. Okay, higher strengths such as DP, CP, trip, and TWIP, which aid in reducing component size and weight. Okay, this DP, CP, trip, and TWIP is on advanced high strength steel, or we call it AHS, the new generation of steel that makes your car stronger, lighter, and safer. Okay, now we are going the step development first about the advanced high strength steel. Okay, first have steel development. What is the steel development? Development is different alloying and process combination to produce steel microstructures, providing higher strength for reduced steel section size and weight. Okay, this combination of high tensile strength and ductility carefully select chemical compositions and the multiple microstructures of AHSS are designed to help the automotive industry meet low weight requirements. Okay, steel development too are not significantly lighter than traditional steels, but their strength allows automakers to manufacture very thin gauge, thus reducing the weight of the vehicle. Okay, second is a classification about the AHS. Require number 2 is a classification of steel for automotive use. Okay, 30 steel grades that are used today in the automotive industry and can be classified into 3 different designations, which is metallurgical designations, strength designations, formability designations. Okay, what about the metallurgical designations? The metallurgical designations provides information about compositions, process, and microstructure of the steel. Okay, the terms HSS and AHSS are generally used to designate or the higher strength steels. Okay, we can see it. AHS called extra high strength steels or ultra high strength steels is exceeding 780 MPa and 1000 MPa. Okay, the terminology designation used to classify high strength steels varies considerably throughout the world due to the constant development of new generation. Okay, for the formality of steel is defined as its ability to be formed into simple and complex shapes by different manufacturing process. Okay, the importance about characters the formality height, word hardening, response, and total elimination. We are going traditional mild steel. Okay, mild or low carbon steels steels with a tensile strength of 400 MPa and carbon content of 0.05% and into 0.25%. Okay, mild steels are commonly used in the body structure and truck colours of vehicle. This is a mild steel, high strength steel. You can see the yellow color is extra high strength steel and the red color ultra high strength steels. Okay, so it is low strength and this blue high strength and this part extra and in car has ultra high strength steel. Okay, next we are going the high strength steels. Okay, how about it? Okay, high strength low alloy, or we call it HSLA steels, where the first commonly used high strength steels in the automotive industry. Okay, they have a low alloying and carbon content to retain firmability and weatherability. Okay, with copper, titanium, vanadium, and niobium add for strengthening purpose. Okay, the principal difference between conventional HSS and AHSS is in their microstructure. AHSS are multiple steels with complex microstructures that contain pairs such as ferrite, martensites, bayonets, and austenites. Okay, about the first generation of AHS include dual phase DP, complex phase CP, methanocytics MS, and regular transformation include plasticities, or we call it TRIP. Okay, what is mean DP? DP is still have a tensile strength from 590 to 1400 MPa and are used in the crash zones of the vehicle. Okay, CPs also still have a microstructures consisting of bayonets in addition to manticides and ferrites, which makes them more formable than DP steels. Their tensile strength range from 800 to 1180 MPa and are generally used in car frames like this. Okay, what are the trips? Trips still have tensile strength ranging from 590 to 1180 MPa. Okay, the microstructure is transform. The microstructure is stitched together with ferrite and methanocytes, contain austenite, which when steel is deformed transforms into strong methanocyte paste, and it can absorb a large amount of energy. Okay, MS states are the hardness steel class in the AHS family. Okay, their strengths range from 900 MPa to 1700 MPa. Okay, these steels maybe have the highest strength, but due the higher amount of methanocytes formation in the microstructure, they have the lowest formability. First, we explain about the first generation of AHSS. So now we going to the second generation of AHS. Okay, what the second generation about the AHSS? Okay, the second generation of AHSS includes a new generation of transformation induced plasticity, hot form HF, and twinning induced plasticity, or we call it twin steels. Okay, but the first and second generation of AHSS are designed to meet the functional performance demands of certain parts in the automotive industry. Okay, the formality of the second generation is significantly higher than the first. So the second is more higher still than the first generation. Okay, the high cost of alloying elements, they are very expensive. The third generation of SS is currently under development. So for now, the manufacturing use the second generation. Okay, they still aim to have improved stretch, ductility ratio, and accepts to achieve over 35% in such a weight reduction. Okay, this is about the AHS grades. Okay, we can see the mill HSLA, TRIP, DP, CP in 100 and 1000 strength. Will the use is 40%. So the third generation not used yet because it is under development. Okay. Now we are going the significance of AHSS. Okay. The significance replace approximately 60% of currently used conventional HSS. Okay. Big manufacturer at varying gauge and maintain the same strength as mid steel designers can easily replace conventional steel with AHS. Okay. It's not the case when replacing steel with other lightweight materials such as aluminium or fiber-force composite materials. Okay, materials are expensive, incompatible with existing manufacturing process, and have higher production and manufacturing costs. Okay, cost benefit analysis show the steel parts are stronger than cheaper than other lightweight materials. Okay, aluminium used in automotive industry has been rising modestly. Okay, body structure, aluminium costs 60% to 80% more than steel. Okay, next about the feature of AHSS. Okay, new grade of AHS are making vehicle body structure lighter by 35% to 39% compared to conventional steels. Okay, vehicle weight reductions is a crucial factor for fuel efficiency. Using a lower amount of steel per vehicle reduce both material and fuel cost, thus profiting the environment. Okay, automakers were to use steel with a tensile strength of 1000 MPa instead of 500 MPa. Steel consumption would be reduced by half. This is a figure about advanced high strength steel market. Okay. From 2017 until 2023. Okay. Automotive. This is automotive graph. This is constructions, and this others. Okay. For the use high strength steel, the automotive have used more than construction and others. Okay, next. This about the challenging manufacturing process in automotive. This weight reduction. Okay. The first thought often start with low density materials such as aluminium, magnesium, or carbon fiber. Reinforced materials resulting in a negative perception of traditional steels because of their high density. New steel grade with higher strength has allowed designers to achieve amazing clash performance. Okay, by using AHSS in the body structure and enclosures, where each load bearing dominant part is replaced by AHSS. Okay, the mass reduction is accomplished because a smaller, thinner part made from AHS can be bear a little load. Okay. The mass reduction also used by same vehicle using low density alternative materials. Okay, a cost benefit analysis show the steel parts are but stronger than cheaper the parts made from the other alternative lightweight materials. Okay, steel vs aluminium in automotive production. Okay, there has always been competition between materials in automotive industry, especially between aluminium and steel. Yeah. Advantage of steel over aluminium is steel's viability, strength, and affordability. Okay. Steel widely known for their higher yield, strength, and ductility compared to aluminium. For example, okay, the body design of Cadillac cars would not be possible with aluminium, as creating complex shapes from, or we call it CP, from aluminium sheets is difficult to achieve with aluminium low formability. Okay. For me, aluminium sheets has always been expensive and difficult. That's why many manufacturers use the steel about to create a body, the frame. Okay. The use of aluminium. Okay, about the aluminium, weight reduction is comparison to standard automotive steel and AHS. Aluminium in the use in the car, not many too than about the steel, because it about the formability production. Okay, this table about weight relation and cost increase. First, we can see that the materials is AHSS. Okay, by weight reduction is 50% to 35%. Okay, about the cost, 100% or 150%. About the cost per part. Okay. Okay, second, glass fiber. Okay, their weight reductions 25% until 35%. And same with AHS, their cost per part is 100 to 150%. Okay, aluminium, the weight reduction about 40% to 50%, and it's very expensive with the AHS and glass fiber, about 130 to 200%. Okay, use the magnesium, the weight reduction is 55% to 60%. Okay, by cost per part is 150% to 250%. Okay, carbon fiber composites. Yeah, weight reduction is same like magnesium, about 55% to 60%. At the most very expensive by all the material, cost apart by 200% until 1000%. Now we are going to composite material, the challenging of automotive. Okay, composite materials have a high purchase price, but view from an economic point of view, they often still make sense. Like we still can buy the composite materials. This okay, they have significantly low weight, good strength and rigidity, good corrosions resistant, and very fuel efficient. Okay, despite this advantage, fiber composites materials will remain expensive due to their high manufacturing costs and also still viable only for certain applications. Okay, manufacturing composite parts is between 1 and 5 minutes, whereas stepping steel parts only take 10 seconds. Reducing the manufacturing time is underway and the composite industry continues to explore process and manufacturing solutions to develop lower cost materials that can meet automakers' needs. Okay, now lastly, the final talks about the challenging manufacturing process in automotive. This is a final talk. Okay, the advantage of many of these alternative lightweight materials, they are still too expensive to make it into mainstream usage because we have a lot use and not enough space to do the alternate to do the lightweight materials. The mechanical and weight advantage of thin AHSS sections compared to aluminium will continue to make it the material of choice over other alternative lightweight materials. Designers must balance structure, performance and life cycle costs with the material costs with steel and aluminium. While AHSS proves to be a low cost material, the resulting maximum weight reduction from replacing milled steel by AHSS grades is limited to 25%. Like we see the table, the weight reduction is 50% and to 25%. Okay, the rapid adoption of new technologies such as the upcoming third generation of AHSS weight saving are expected to improve even further. Okay, so they want to use the second generation until now because the third generation AHS not official because they are under development. So the final thought is about the cost and the materials. Okay. That's all from me. Thank you.